pretty nice conference you got here. It'd be terrible if some Golang happened to it. So there's going to be a lot of Golang in this. I'm going to move this. If you're not a fan, the restrooms are right over there. If you need to take a restroom break, I won't be offended. Cory Daniel, one of the co-founders of Massdriver. We're a visual development environment for managing cloud infrastructure. We help startups to large platform engineering teams manage cloud resources. The goal is to let developers focus on apps and their cloud dependencies, not all the glue of the cloud. So we take care of provisioning, workflows, IAC state, secrets management, IAM, preview environments, alarms, metrics, all that stuff. And like that sounds cool, lots of interesting stuff there, but like really the goal is to let developers write code and not worry about all the glue. So that's what our customers love most about us. Oh man, I've been in this Elixir thing for a while. Years ago, I was consulting for Google Cloud, and I was leading and organizing large-scale data center migrations from on-prem to GCP. I was doing a lot of work in Kubernetes, and you got to write Go there every once in a while. And so I did what all good developers do. I reinvented the wheel, so I didn't have to use something I didn't want to use. And I wrote Bonny, which is an operator development framework, and KCX. But now I work on a cloud platform, so like everything is in Go. So now I'm here. So Terraform is in Go, Kubernetes is in Go, a lot of the cloud native compute foundation tools are in Go. And I couldn't convince my co-founder Chris to write his side of the business in Elixir, so here we are. And so this is pretty much how I feel every day. Like I go back and forth between Elixir and Golang. I'm berserked like that. Like it's partially code. It's also partially like founding a company. By the way, we just closed this is brand new news. An hour and 20 minutes ago, we just closed our financing round. So, woo! Yeah. Stressful morning. I had to do that and put together this slide deck. But it's funny, like when I go back and forth, like there's things I miss about each language. And when I'm in Golang, I miss pattern matching. So pattern matching in Erlang is actually how I got introduced to Erlang. We leaned into it really heavily at a company called Deal Science. So we had 17,000 partners, and we turned each of these people's websites into essentially like a REST API. So we pretty much reversed what we do in a lot of templating, so like render pages. Like we'd look at the page and turn it into a REST API. And this was thousands of lines of Ruby originally, and we're always getting these new partners. We had 2 developers. We get a new customer like Gap. Now 2 developers are writing a bunch of code to like essentially crawl and turn this thing into an API. And so how I got into Erlang originally was we needed to do these really complex matches and find things kind of dynamically in these sites and pull stuff out. And so we made a browser extension that would let our biz dev people click on stuff on a website that would actually write pattern matches in Erlang. It would get merged into our code base, and then we'd hot reload the servers, and now their site's an API. So love pattern matching. Now, one thing I don't miss, oh man, I'm ready for it. One thing I don't miss when I'm in Golang is the pipe operator. How you guys feel about that? So at the after party tonight, grab me after 2 margaritas and we can talk about why. But when I'm programming Elixir, there's a lot of stuff I miss about Golang. And so that's what this talks about. And to be clear, is Golang a better language? No. Absolutely not. All programming languages are terrible. If you find one that makes you feel good about trying to convince a computer what to do, congratulations. Okay, let's get into this. So this one I hemmed and hawed about. And it's really funny. It's like, I love this about Golang. And I was trying to figure out like how to show it in code in an interesting way. This is one of the cornerstones of what makes Golang simple and efficient. And then as I'm working on the talk, I'm like, oh, fuck, we got this. This exists in Elixir, like it's protocols, but we don't really use them very often, right? And like this is a bedrock of what makes Golang so flexible, and it's a general theme of the rest of the talk. So I'm going to talk about it a little bit. I'm going to show like how this kind of compares to protocols and why it makes Golang particularly interesting. But we have them. Like, this is the Elvis Presley of Elixir protocols. Like, everybody recognizes this one. This is the one everybody uses, right? Does anybody not work with JSON? Why isn't this in the standard library? I'll just leave it at that. I'm going to move on to the next thing. Right. So Golang interfaces. This is the exact same thing. Saying the exact same stuff here. Little less code. There's some key differences. So one is in Elixir, protocols are explicit. You have to implement every single function, right? In Golang, they're implicit. If there is 10 functions in the interface, I only have to implement the ones that my code uses. And at compile time, the compiler verifies this. In Elixir, it's runtime, so maybe things will crash, and maybe we're fine with that. Also, like how you kind of implement it, it's a bit different, right? In Elixir, it's functions that aren't a part of the module that you're talking about or the struct that you're talking about, whereas in Golang, it's a struct or it's a function within the struct. But I think the key difference is Golang leans into this, and we avoid it, right? And I can prove that we avoid it. Unless my grep sed awk skills suck, this is the extent of protocols in Elixir. And then the only one that any of us know, down here at the bottom. Again, it's not in the standard lib. These are the ones I could fit on a slide from Golang, right? And so it's core to the language. It's core to how you can extend and compose things. And you might be looking at this saying, I can't read any of that, or you might be close enough to say, JSON, web servers, image manipulation, databases. I thought you said this was a standard library. It is. Like, this is one of the other things that's really powerful about Golang. Its standard library is pretty impressive. Now, of those interfaces, this is the best one. And it's funny because people hate this about Golang. Like, you're always checking errors. And I'm completely honest, this is the best one. And the reason why is it defines at the language level how all libraries and all software are going to handle errors. And we can do this a bit with like an error tuple, right? But like, what's the second element, but first, in parentheses, what's the second element of an error tuple? YOLO, who said that? That's right, that's what I have in my notes. Yeah, is it an atom? Is it not a tuple? Is it just an atom? Is it a string? Is it an ectostruct? Is it a 3-element tuple? We don't know, we'll figure it out, right? Like, in Golang, we say what this looks like, and everything just implements an error function, or it's a string, and this is pretty nice. What if it was always a protocol for us, right? So our GraphQL API is written in Elixir. We federate a ton of different services. HTTP services, we interact with Postgres, S3, SQS, all the things in the cloud. And every single one of these things has a different way of bringing errors back that has to be munged and manipulated to get it into the idea of what we think errors should look like coming out of a GraphQL API. In Golang, they make all these decisions for us, and it's nice. I don't think about it. I go for about it. This one's the most powerful. At the core of the language, they define how HTTP is served and how middleware is written. It creates a lot of flexibility. I can use middleware between web frameworks. Gorilla Mux, standard net HTTP library, any function that implements this interface is a middleware. I don't have to have a big library for it. Just simply implement this function, and I can bring them from framework to framework. This is by far the most powerful, because you can make your own interfaces, right? And so it makes it really easy to mock I/O in your tests. This is where you see it the most. You definitely see interfaces in your code, but in tests, this is where it's really beneficial. And so what's going on here is I got a real simple interface for what my to-do database might look like. It's got a get function that takes a string, returns a to-do item, create function that takes some params, list, etc. And then I've got a fake database implementation that's just always telling me to wash the dog. The dog stinks. They do, they always stink. So what's interesting with this is you will see this frequently in Go test code for, let's say, interacting with external third-party APIs. So instead of bringing in some heavy HTTP mocking library or doing all sorts of weird pain, booting up ports to mock stuff, you can just do a simple interface implementation to mock how your HTTP client's going to respond. Okay, so earlier we saw a bunch of stuff on those interfaces, the standard library. The standard library is fantastic. It has web server implementations, SQL interfaces, image manipulation, embedded file systems, which we'll talk about a bit more, CLI, and flag parsing, and HTML templating. You can do a lot in Golang with, I'm purposely slowing down because I can see the GIF on the next slide is not at the right point. So you can do a lot with very little. So I was trying to do an experiment and see how far I could get on the airplane, come on, GIF. How far I could get on the airplane with no dependencies. And so I didn't get as far as I wanted because airplane whiskey, but what we got here is, so this is a make file that's hitting a CLI. So I got this to-do CLI. It's got multiple subcommands. Here's a client. I'm calling this new function, write presentation. This is important because I didn't do this till this morning. But it's the server, it's the client. It's a static web server built into it that's serving that page. A basic SDK for any customers of mine that want to implement my API. 5 megabyte binary, literally no dependencies. Finished it in less than 5 hours in between 0 whiskeys and more whiskeys. So there's a lot in there, but here's one that's really interesting is the package management. And this, like, if you haven't programmed in Go, this might be the thing that you know that everyone hated about it. A few years ago, it was terrible. Go mod has really changed the game here. But the core thing with Go is there is no central package manager. They don't have a Ruby gems. They don't have a hex. You point at URLs, and that is the packages that you pull down. So you can point them at something like GitHub. You can point it at a tag. It's nice. It's very easy to navigate to the actual source that you're downloading, right? You're not going to hex, hoping that's right, hoping you don't have some supply chain attack. And what's really interesting here is modules are sets of packages. So you can actually have like multiple packages like layered deeply in Golang. And a package is literally just a directory full of code. That's it. That's the extent of a package. And this is reminiscent of like Google's infamous like monorepo, right? Like you can see where this inspiration comes from. But what's neat about it is if I need something from a library and it's not in its internal package or its internal API, I can just grab it. So let's say I wanted to do something with the router from Phoenix. I don't have to pull Phoenix and all of its dependencies to get to that router. I could literally just say, I want the router. That's all the code I bring down. That's the extent of my dependencies. I'm not dependent on Phoenix. I'm dependent on simply its router. And what I love about this is, I don't know, who's seen the mess we're in? The mess we're in. This reminds me of like the hashed file system that Joe was talking about, right? Write the thing once and be able to get to it in a consistent place where it's hashable and verified. And that's what Golang's package manager does. Embedded file systems. This one's weird. If you're building CLI tools, this one's really, really, really powerful. It's very similar in concept to like your private directory in a release. Like you can ship around files with your application. These are actually embedded into your binary. And the really cool thing is the embedded file systems implement the same interface as regular file systems. So if it's in memory, it acts and behaves to all code just like a file would off of disk. You can read it, et cetera. Companies like HashiCorp Vault, they use this, so you have a CLI that is the server and the client, and the server will actually run a web interface. You download a tiny little binary, and like the web server is built into the binary. Other cool cloud ops companies use this too, like Massdriver. And so we use it in our CLI for our docs. So we do these really rich markdown docs that we render in our CLI. We want people to be able to understand how things work, see examples, et cetera. When we release our CLI, these markdown docs that are burned into the binary also ship and render on our document site. So you get the same docs in both places, and Google can crawl them and serve up results if people are searching for things. So the embedded file systems are pretty cool, and this is what it looks like when we render it into our documentation site. So it's just a really nice way of shipping around resources, assets, et cetera. Okie doke. This is prevalent in Golang. They're all over the place. And most of the things that I've talked about so far, like we can't really do an Elixir, wouldn't really benefit, but struct tags are amazing. And I think this is something somebody should go do tonight instead of going to the happy hour. You should go add this. Seriously. Don't go to the happy hour. Somebody go work on this. So what these are is they're metadata that you can attach to a struct's field. And the reflection engine in Go can interact with this metadata to determine like how to work with a struct. And so where you see this the most is in JSON serialization. I'm not telling my JSON serializer how to, like if I have a map and I need to change how the keys are shaped or how they're cased, right? That's annoying. I can literally have my code this way and I can say, hey, when you do this to JSON, it's gonna be lowercase name. Or maybe omit this field completely. Right? I don't have to write a bunch of code for it. The language understands how this works. The underlying JSON serializer, Marshall unmarshaller, knows how to handle this. We see it in configuration management. So if I need to pull something from an environment or from a config file, I can actually come in and say, my port is going to come from my config file. It's going to be in the port field. Override it with the environment variable port if it's set, right? And you also see this when you're doing GraphQL queries. I can actually put the query fragments alongside my struct, and now when I fetch from GraphQL saying I need to pull a human, it knows where to get those values from the graph and where to put them into my struct. Now, where this gets really interesting is we go back to JSON struct tags. We can start combining some of the features that I've talked about here. So if I publish my API's structs in a package that my customers can access. And structs in Golang, people are a bit more free with them. Like if I have an item, I probably end up with like 3 structs. I have my internal representation of an item, and then I'll have like an item request and item response for like the request response cycle. You actually define these things instead of just working with like vague bags of params. And so what's really cool is I can publish these in a public package, I use them, and my customers can just grab them. If they have a Go application and they need to make requests to add an item to their to-do list, they don't really have to figure out how to serialize and deserialize anything. They can just grab this one struct, send it through to the HTTP server, and off it goes. Okie dokie. So this one right here. Am I talking too fast? This is going way faster than I practiced it in my room this morning, a little hungover. No? Okay. I love tests. I'm actually a person that cannot work outside of a TDD loop. If you put me in a computer and I can't write tests, I just literally can't code. And what's funny is when I first started coding, I did something called cowboy coding. I don't know if this is a real term or if my co-founder at the time just liked to call me that because I also had like a Florida accent. Is cowboy coding like a real thing? Yes. Oh, it is, okay, because I was just like, yeehaw, I'm just gonna put something in prod. And so my co-founder at the time, he was very into TDD, and he was just frustrated with like, I was 23, I knew everything in the world, like my code's just gonna work, I'll just write it and refresh the browser 6,000 times until it actually does. And so he was adamant about me trying TDD, and so we made a $500 bet, and the bet was, if I spent 3 development cycles doing TDD, I would lower my cadence, I'd match it, and then I'd go above my cadence, like historically. I want to say I lost $500, and I love TDD ever since, but he actually never cashed the check because I post-dated it because I didn't have any money because I was a startup. So I love testing, though, and so this is one of the things that we can do, and I think we should do, and I'll be honest with you, I'm not the smartest person in this room by far. I spent a few hours trying to do this, and I could not figure out how to do it. So if anybody works on XDoc or XUnit, and you want to talk tonight, let's talk a little bit. One of the first things I saw when I got into Elixir was doc tests, and they blew my mind. And in KZX, if you go look at the code base, almost everything has a doc test. Kubernetes operators are complicated. Kubernetes is complicated. I wanted to make sure that my tests and my documentation were correct. I want to write tests, I want to know everything works, and I want people to know that it works, and I don't want my docs to be wrong. Doc tests suck though, right? like, look at this. A multi-line string under examples, nested in a bit with this IEX thing, with some ... Like there's a lot of effort to get doc tests to work. And the worst part is like, oh, there's a bunch of Kubernetes shit here at the bottom, so ignore that. But like, there's no syntax highlighting unless I go install a bunch of different extensions. Like it is hard to do this. It's hard to do this, but it's such an amazing idea. And Golang has this, but they do it the opposite direction. They flip the idea. They have something called example tests. You write a regular test alongside the rest of your tests, and instead of starting with the word test, all the tests in Golang start with the word test, by the way. Kind of ugly, but we won't mention it. If you start it with example, it runs with your test suite. It's alongside all the rest of your tests. It can use all the setups, all the other configuration that you do to get your tests running. And then it renders it into the docs. Just a little flip. So, why did I write this talk? So, some people say it was because of a shitpost. Maybe a little bit. But in part, I just really want the nerds type everybody. Like seriously, somebody smarter than me, struct tags and example tests. What do I got to do? Like that's what I'm up here trying to do is get this stuff implemented. If we could do it this weekend, I'd be really excited about it. I don't know if anybody's got anything going on later, but like bring your laptop to the bar. But what I really wanted to do was kind of preach the gospel of the gopher, right? I think it's important to work with other languages, work with other tools. We need to have lots of things at our disposal to solve problems. It makes you a better engineer, it makes you more marketable, and it's important to appreciate the differences of other programming languages and see how it can influence your work and what your language can learn from it. So that's really what I want to do. I hope you all implement those features this weekend. Thank you.